Good morning, dear students. This is for 4th semester mathematics honors. So today's topic is central orbit. So let us write the topic. So what do you mean by, first question is, what do you mean by central forces? Suppose a force acting on a particle of mass m is such that it is always directed towards or away from the fixed point O, then it is called a central force. And number 2, its magnitude depends only on the distance r from O. So here we want to find out the differential equation of a particle moving under a central force. So let's see how we proceed. So taking the center of force O as the pole and a fixed line OX in the plane of motion as the initial line. Let P r comma theta is the position of the particle and F is the force acting towards O. So F is the force per unit mass. So take a note of this, that per unit mass and the particle F along PU. The equation of motion of the particle, we know that the equation of motion of the particle along the radial and cross radial direction, along the radial direction and perpendicular to the radius vector, that is the cross radial direction, can be written as m d2r dt2 minus r d theta dt whole square equal to minus ff. That is, it can be written as equation 1. Number 2, the cross radial direction is ddt of, as there is no motion in the cross radial direction, as you can see there is no motion in the cross radial direction, so ddt of r squared d theta dt equal to 0. From this equation 2 we get r squared d theta dt equal to constant, with the constant is taken as h. So d2 theta dt2 equal d theta dt equal to h u square, where u is equal to 1 by r. Now r is equal to 1 by u, so we can find out easily dr dt as minus h du d theta, and d2r dt2 as minus h u square d2u d theta 2. Using 3 and 4, 1 becomes, substituting 3 and 4 in 1, we get the final differential equation of the particle, path of the particle in polar form. Let us now find out the equation of the differential equation of the particle in Petal form. What is the Petal form? We know that Petal form means P and R. What is P? P is the perpendicular length of the perpendicular from O on the tangent vector. So again, writing the differential equations as in the previous case, the length of the perpendicular P OM, which is in this case is OM. We know the relations. If OPM is equal to phi, then we know tan phi is equal to r d theta dr, also P is equal to r sin phi. These are the known results. So we get this thing after some manipulations. 1 by p square is equal to u square du d theta. Again we are using the relations, u is equal to 1 by r. So naturally we get the differential equation 1 by p square is equal to u square plus du d theta whole square, differentiating with respect to theta, and after some manipulations using the relation u is equal to 1 by r, we get the Petal form of the differential equation, a square by p cube dp dr equal to f. So these two are very important differential equations. One is in the polar form and other is in the Petal form. So these two equations are very useful and very important for the students of semester 4 mathematics honors, topic mechanics. Thank you.